discussing about motion of center of mass. Right? So yesterday we discussed about center of mass. Center of mass means the point which appear to act like whole mass is concentrated at that particular point, right? And we also discussed how to find center of mass for the system of particles. If two masses are there, one mass is there, one mass is here. This is M1, this is M2. They separated the distance r. Then from M1, center of mass will be M2r by M1 plus M2. From M2 it will be M1r by M1 plus M2. And it will be negative because you are measuring the distance to negative x-axis. And you have n number of masses. Right, on a coordinate system in a straight line, you have the formula RCM equals to M1 R1 plus M2 R2 and so on. Mn Rn by M1 plus M2 is the formula. If they are not in straight line with the two-dimensional plane, then we should find coordinates. XCM M1 x1 plus M2 x2, so on. Right? Right. So these are the things we discussed. Like similarly, you have YCM also, ZCM also. So these are the things we discussed in yesterday's class. For example, if two masses are there, this is M1, this is M2, they are separated at a distance. If both are same masses, then center of mass will be lies at the center. For example, this M1, this particular mass moving towards M2, right? This M moving towards M2, towards this body. Then what about the position of center of mass? Will it change or not? Do you understand my question? So this is moving towards this body. What about the position of center of mass? Will it change or not? It will change. So it will also shift. Right? It's like this because the mass here they are separated with a certain distance. Now they are coming closer. Right? Coming closer means the distance decreases. So R decreases. So RCM also changes. Right? For example, this body alone moving that side. That time also center of mass will change. Center of mass will move. Both are moving towards each other. That may change, may not change. Based on speeds, right? If they are moving away also, based on speeds, it may change, may not change. So what we can understand here, center of mass can move if the system is moving, right? So now how to find? So when it is moving, it will be having speed, it will be having acceleration, it will be having momentum, right? So now if you consider speed of center of mass or velocity of center of mass, right? Generally speed equals to what? Dx by dt. Rate of change of position by time. So if x is what? If it is x, you can consider this as dr by dt. So what is r center of mass? The position changes, then you will be moving it, you will be having some velocity. So here we can write d by dt of m1 x1 plus m2 x2 by m1 plus m2. If two particles are there, n number of particles are there, means so this m1 plus m2 is constant. So we will write here m1 plus m2 will be there, and d by dt of m into x1 plus m into, this is m1, right? m1 m into dy by dt of, taken R here. So you can know this is R1, this is R2. Right? So dr by dt will be what? Change of rate of change of velocity. So it will be m1 v1 plus m2 v2 by m1 plus m. What is this? Velocity of center of mass. So velocity of center of mass formula is this. Now we want to find acceleration of center of mass. If velocity changes, we will be having acceleration also. Right? So acceleration of center of mass. Acceleration of center of mass will be, so the ACM equals to what? D by dt of VCM. That means you can write here m1 into dv1 by dt plus m2 into dv2 by dt whole by m1 plus m2. So acceleration of center of mass will be m1 dv1 by dt will be a1 plus dv2 by dt is a2 m2 a2 by m1 plus m. So this is the acceleration of center of mass, right? So this is the acceleration of center of mass. Now, for example, n number of particles are there, n number of ones are there. Acceleration of center of mass will be what? m1 a1, m2 a2, right? So this is this m1 plus m2 plus m3 plus mn is what? Sum of the masses of the system. So this here you can replace capital M. What is capital M? Total mass of the system, right? So we can write m1 a1 plus m2 a2 plus m3 a3 and so on mn an by total mass. This is what acceleration of center of mass. Now if you bring this m here, m into a center of mass equals to and so on mn. So this m into a is what? Force. So this is net force acting on the system. So this is what? Force acting on first mass. Force acting on second mass. Right? So this will be F net. F net equals to this is F1, F2. Right. So the force acting on center of mass is nothing but sum of the forces acting on individual masses. Right? So this is one thing. For example, if net force is 0, if F net is 0, then acceleration of center of mass will be 0. Right up. Acceleration of center of mass will be 0. So you take this one, this equation. It will be 2 particles of n number of particles. It will be same only, no? So m1 v1 plus m2 v2 by m1 plus m2 equals to 0. Right? So m1 v1 plus m2 v2 equals to 0. So m1 v1 plus m2 v2 is what? m1 v1 is m1 v1 mass into velocity. Mass into velocity density. V means not always volume. So this is momentum 1 plus momentum 2 equals to 0. Do you remember something from this? Linear momentum conservation of linear momentum. Conservation of linear momentum is what? If there is no external force, then momentum of the system is conserved. So there is no external force. Momentum of the system is constant, right? So this is about motion of center of force. So heading is motion of center of force, right? You copy this. We will solve a few questions on this. So the question you see, 20th. Two particles A and B initially at rest move towards each other under a mutual force of attraction. At the instant when the speed of A is v and the speed of B is 2v, then speed of the center of mass. What they said, there are two masses, m1, m2. They are moving due to the mutual attraction force. Mutual attraction. So it is moving with v1. It is moving with 2v. Masses, two different masses, initially at rest, right? So initially at rest, now they are attracting at some instant. It is at v1, where is it 2v, right? Now what will be the velocity of center of mass, or what is the speed of center of mass? We need to find. What will be the velocity of center of mass? Velocity of center of mass, for example, is here. There is information only given, right? There is no masses mentioned. Masses, these are equal masses. No, right? Two particles A and B initially at rest move towards each other under mutual attraction force. The speed of the center of mass they are asking, right? The first thing what we need to understand, they are moving under internal force, right? They are moving under internal force. So, due to the internal force, center of mass will not be accelerated. Do you understand the point? Due to the internal force, see there is no external force. F external equals to 0. That means momentum of center of mass will be constant. Momentum of center of mass will be constant. When momentum of center of mass is constant means what? M into VCM is constant. So that means there will be no change in velocity of center of mass. Initially, what is the velocity of center of mass? Initially both are at rest. So velocity of center of mass also will be at rest. Right? It is constant. So throughout the motion it will be at rest. So velocity of center of mass will be 0 because initially it is at rest. Right? You see the next question. Level 1, part 2, motion of center of mass. Okay, I will read the question. You can hear. So the question is: a bomb of mass 9 kg explodes into two pieces of 3 kg and 6 kg. It explodes into two different parts, 3 kg and 6 kg. The velocity of 3 kg piece is 60 meter per second. Kinetic energy of 6 kg piece. So a bomb is there. It is 9 kg. It exploded into two parts. One is 3 kg, other one is 6 kg. Right? The velocity of 3 kg is 16 meter per second. It is moving with 16 meter per second. What is the kinetic energy? Kinetic energy of this we need to find. Right? Now this question we already solved earlier also, these kind of questions. Do you remember? In conservation of momentum. Here there is no external force acting, so momentum will be 0. So m1v1 plus m2v2 equals to 0. So m1, you know m1 is 3 kg. 3 into v1 is 16 meter per second. This m2 will be 6 into v2 equals to 0. So v2 will be what? minus 3 into 16 by 6, right? So 3 2s are 2, 8 minus 8 meter per second. So kinetic energy will be what? Half into m2 into v2 square. So this half into m2 is 6 kg into v2 is 8 minus 8 whole square. So 3 into 8 square is 64. 3 into 64. 192. 192. Right. By using conservation of momentum, you can solve like this. If you want to use center of mass only, velocity of center of mass will be 0 because it is internal force. So velocity of center of mass will be 0 means m1 v1 plus m2 v2 by. So VCM is 0. That means what? m1 v1 plus m2 v2 by m1 plus m2 equals to 0. So if you send here again, you are reaching the same point. Right? The question is what? A boat is there, 200 kg, a person of 50 kg standing on it. The length of the boat is 25 meter. He starts running from the one end. When reaching the other end, the speed becomes 2 meter per second with respect to boat. This 2 meter per second with respect to boat. Right? Now, what will be the acceleration that we need to find? What we need to find at the end? What is the velocity of the boat? Finally, what will be the velocity of the boat? We need to find. So, first we need to find acceleration of the person. So, distance is 25 meter. Final speed is 2 meter per second. Initial speed is 0. So, acceleration we will find S equals to ut plus half a square t we don't have. So we can use v square minus u square equals to 2as. Acceleration we need to find s we know. So from this a equals to v square minus u square by 2s. Right? So v is what? 2 square minus 0 square by 2 into 25. So this is 4 by 50. That means 2 by 25 meter per second square. Let it be in the fraction. So this is what? Acceleration. Acceleration of the man with respect to boat. So this is the acceleration of man with respect to boat. This equals to 2 by 25. 2 by 25 meter per second square. Right? But we need to find the acceleration of the boat to find the acceleration. To find final velocity. So what we do? So acceleration of man with respect to boat will be acceleration of man with respect to ground minus acceleration of the boat with respect to ground. So this we know. And acceleration of man with respect to ground, do you know? Acceleration of man with respect to ground. We don't know. Acceleration of boat also we don't know. We will see. Acceleration of man with respect to ground will be acceleration of man with respect to boat plus acceleration of the boat with respect to ground. Right? This we know 2 by 5. So we will try to find. Acceleration of center of mass will be 0 because there is no external force acting. So acceleration of what? So we know m1 a1 plus m2 a2 equals to 0. By m1 plus m2. M1 is what? Mass of the person 50 kg. A1 is what? Acceleration of the man with respect to ground, that we don't know. So M2 is 200 kg. A2 is acceleration of the boat with respect to ground. Right? You substitute 200 into A2 equals to 0. We have acceleration of the man is A1. So A1 we can substitute acceleration of man with respect to board plus acceleration of board with respect to ground plus 200 A2 equals to 0. Acceleration of man with respect to board is this. Acceleration of board with respect to ground is A2. Right? We substitute this. 50 into this is 2 by 25 plus this is what? A2 plus 200 A2 equals to 0. So if you write separately, this will be 4 plus 50 A2 plus 200 A2 equals to 0. So 4 plus 250 A2 equals to 0. So A2 equals to minus 4 by 250. Minus 4 by 250 means over 125. 2 by 125 meter per second. So that is the acceleration of board. Right? Now what we need to find? Final velocity. Final velocity of board, how will we find? But distance traveled by the boat we don't. Right or wrong? The person traveled from here to here with respect to the boat. But distance traveled by the person, distance traveled by the boat we don't know. Distance traveled by the person also we don't know. Do we know distance traveled by the person? That is with respect to boat. But boat also moving this side, right? Right? Boat also moving this side. Now, actual distance traveled by the person with respect to ground will be, for example, boat travel 5 meters. What will be the distance traveled by the person? 20 meters only. Yes, sir. You understand? So, acceleration we know. So, if we can find distance traveled by the boat, then it will be, we can use the same formula to find final velocity. So, what do we do? We'll see. So, this boat is there. Here is the person. He traveled. He reached here. By the time he reached here, for example, the boat traveled some distance. Somewhere over here. You consider the distance traveled by boat is x. What will be the distance traveled by the person? 25 minus x. So R1 will be 25 minus x, R2 will be x. What is the position of center of mass? Position of center of mass, is there any change in position of center of mass? Body is moving. Position of center of mass will be, there will be no change in position of center of mass. Why? Because there is no external force. Is there an external force acting? No, right? So RCM will be 0 only. If we initially here, the position of center of mass will be there only. Position of center of mass of systems, not board. Position of center of mass of the board will be moving. Center of mass of the person also will be moving. But the center of mass of these two will be somewhere over here. Right? That will not change. So we know M1 R1 plus M2 R2 by M1 plus M2 equals to 0. Right? So from this M1 R1 plus M2 R2 equals to 0. M1 is what? 50. So this is 50, this is 200. 50 into R1 is 25 minus x plus M2 is 200 into x equals to 0. So 50 into 25. You give plus 50 into 25 minus 50x plus 200x equals to 0. 1250. Yeah. Let it be 50 into 25 only. Minus plus 150x equals to 0. So x will be what? 50 into 25 by 150. So 51 to 53. equals to minus 25 by 3 meter. Minus 5 because it is moving this way. Right? What happened here? Mistake. See, R1 is 25 minus x, R2 will be minus x. Why? The board is moving this way. Right? Now M1 we substitute the values. M1 is what? 50 into x1 is 25 minus x plus 200 into minus x minus x equals to 0. So 50 into 25 minus 50x minus 200x equals to 0. Right? So this is, you keep this as 50 into 25 only. Minus 250x equals to 0. So x equals to 50 into 25 by 250. So 55 so x equals to 5 cm. Right? Now we know distance traveled by the boat. Acceleration of the boat, final velocity we need to find. So we know v square minus u square equals to 2as. U is 0. We know v equals to square root of 2 into a into s. So 2 into a is what?
Minus 2
Minus y minus because it is moving in opposite direction. So that you can leave 2 by 125 into 5. This is 5. So 5, 25 4 by 5.
4 by 25.
Or 2 by 5. Audible. 2 by 5 meters. Right? So this is how we will solve this kind of question. So this part alone also they will ask sometime. This part alone means what? A person will be standing on the boat. He will be moving the other end. What is the distance traveled by the person? Or what is the shift in center of mass of the boat? Right? Then the same formula. Here the concept is what? When the person is moving, the boat also moving this way. So the distance traveled by the person with respect to ground is not the length of the boat. Length of the boat minus distance traveled by the boat. And the distance traveled by the boat will be minus this. Right? So that is how we will solve this question.